Okay. So be taking something, just jot down some things to note as you go along the way. All right. So I think my screen is clear enough for everyone to see. That's the presenting screen. I hope everybody can see this. It's clear enough.
Yes,
Okay.
yes.
All right. So basically what we're going to be doing now, we'll just try and go over everything. We're going to be focused more on property environment. This is your property environment. Some of us are using version 12. So if you're using version 12, what you just need to do is to open a new case. I think you can see that some of us are using version 12. You open a new case, and then you should be having this environment. All right. So this is version 11 actually, but everything still works the same way. It's just maybe like few things that were added to 14, not really 12. Nothing much was added to 12, but 14 maybe few features, but the main thing we need is actually here. All right. So let's continue. All right. So now the first thing we're going to be looking at, we have the items here. We have the component list. We have the fleet package. We have our petroleum assay. We have reactions. We have component map and user properties. All right. So basically, like I said in the video, before you start any process, you need to know what you are working with, and then we've been able to explain the use of ICs and that of plus. We will also be able to differentiate the two of them from the videos, and then we were able to say that okay, ICs is majorly for the hydrocarbon industry. We are doing oil and gas. Basically, you use more of your ICs for such kind of simulations. But when you are doing anything like pharmaceuticals, any other chemical orientated simulation, you use more of plus for that. All right. So like I said, the first thing you need to do normally, you need to know the components you're working with. It's very important when you know the components you're working with and the kind of process you're trying to do. Whether you're working with natural gas, whether you're trying to do carbon capture, whether you're trying to do maybe like a little reaction in the process, you know the kind of fluid package that you're going to use. So your component list and then the process you're trying to simulate determines the kind of fluid package you're going to select, because not all fluid packages are compatible with the kind of components you'll be using. All right. Um, so basically, the first thing you need to take note of, like I said, is your component list. Very important. Know the components you're working with, and then before you can go to your fluid package. In fact, these are to tell you how crucial this is.
Please excuse me. I hope all these things you're talking, you will give us as a YouTube. We listen to it again.
All right, ma. I'm recording. I'm recording them. So
Okay. Thank you.
okay. All right. Um. So basically, you have to. Sorry. So to tell you how crucial this is, we can see that from the properties, we can see that it's just your component list and your fluid packages that are showing red. You understand? You have the icon of red by the side there to tell you that okay, these two are very important. Without these two, you cannot go to your simulation environment. So to tell you that these two are very important. All right. So basically, if you want to, like I said, we have two component lists. We have that of ISIS and we have the Aspen properties. All right. So your ISIS data bank is basically what you'll be working with for ISIS. That's where you'll be seeing most of your components. And then when you're looking at the Aspen properties, you have other properties coming in from Aspen Plus as well. This way you can also be able to define some things from some of the data banks, that's the components from Aspen Plus, because the ISIS is not doesn't cover everything. You know, like I said, ISIS is restricted. You understand? ISIS is more restricted. You understand, to a particular process, all right, compared to that of Aspen Plus. We're still going to get there. Um, so whenever you're selecting your components, you take note of what's the kind of components you're using, because some of the components you don't find on ISIS data bank, you can actually find them on the Aspen properties. All right. So, but for now, majority of what we're going to be doing is we're going to be using the Aspen ISIS. All right. So I'm going to select my Aspen ISIS first, and then we are going to be looking at the components here. If you want to select your components, there are different ways you can select your component. Is that you click on it once and then add it with this, or you double click on it then send it over here. All right, so these are the way you go about it. And then for your hypothetical components, we've talked about this before. Your hypothetical components are components that they are not found on the data bank of ICs. And then this particular one, you have to define it yourself. You might not be able to even find them on that of Aspen properties as well, but you just have to define them yourself. And then when you're defining it, you have the hypothetical liquid. This one is usually for liquid. The hypothetical, just the hypothetical itself is usually used for liquid components, and then the hypothetical solid is for solid components. All right, so let's just review this a little bit. So let's select our hypothetical, and then coming to this point, we can see where we have creates a batch of hypos. All right, now when you are creating a batch of hypos, that means you are creating multiple hypothetical components, not just one. All right, you are creating multiple hypothetical components. So remember from the I think going further, there are some videos that will be coming up that will show you how to do this properly, but just take note of some of the key things I'm going to be saying here, because this is very important. All right, so when you are going to be working with one component, you just select create and edit hypo. All right, you can see new hypo group. You're not working with new hypo group, but if you have a group you're working with, then you can select your new hypo group. And then if it's just one hypothetical component you're working with, you're going to select this. Now this is very important. I would like you to jot this down, because you'll be asked a question like this on from Aspen Tech when you're taking your Aspen ICs exam. They will ask you what are the two properties you have to impute to define your hypothetical component. All right, and then the two major things you need to define your hypothetical component is your molecular weight and your liquid density. These are the two important things you need to take note of. Once you have your molecular weight and your liquid density, you can easily estimate the remaining things. All right, Mr. Sonto, I see your hand raised. Can you?
Um, so I didn't take note of that. Can you come again, please?
All right, you'll be asked a question. What are the two properties or two specifications you need to define your hypothetical component? The two key, the minimum of two, as the minimum specifications you need, right, to define your hypothetical component. And then you have two. The main two is molecular weight and your liquid density. Those are the key properties you need to define your hypothetical component. All right, once you do that, I can just put, let me put like 280 here. That's my molecular weight, and then my liquid density I can just put, let's say 20. All right, okay, say flash difficulty density lies outside the range of, okay. All right, so let's put like 300 here. That was saying that it was outside the range. That's the range of 290 to about 1500. All right, so let me put 300 here. So now to estimate, I can estimate the unknowns. I can just click on estimate unknowns, and then you can see that the normal boiling point and then the temperature has been given. All right, with some other things, we have the pressure, the volume per mole, and then the eccentricity. All right, so basically this is how you go about it. But the key things you need to know, you need your molecular weight and then your liquid density. If you have the others, you can actually do that, but if you don't have the other ones, you do the molecular weight and the liquid density, you estimate the rest, and then you are good to go. All right, so after doing this, you can just add this to the data bank you're going to be working with. All right, so coming down to fluid packages. All right, so another thing to note here, this is another key thing to note. Anywhere you select your data bank, that's your components from, remember I showed you we have the ICs and then we have the Aspen properties. Anywhere you select your component from, that is where you're going to be selecting your fluid package as well. Very important. Anywhere you select your component from is the same place you'll be selecting your fluid package from. All right. So I selected my component from ISIS data bank. So I'm supposed to be selecting my fluid package from ISIS. This question too will be asked. This question too will be asked too. So you select your components from ISIS. I have two hydrocarbons there with a particular user property that's a physical component. I can easily go for the Robinson. All right. So basically, I think I explained why we make use of Robinson. All right. So I think I explained why we make use of Robinson. It's part of the video that we sent there because we give a list of things why you make use of Robinson, and we make use of it majorly when you're working with natural gases. So that's why you make use of the Robinson. All right. So all right, we have two natural gas in our component list, and then we have um, the hypothetical component stated there at the same time. So we're selecting our fluid package from the ISIS data bank. All right. So let me do something else. Let me add the difference. Let me add from Aspen properties here. All right. So now my component list 2 is from Aspen properties. And then to go about this, you just click on find. Oh, sorry. I'm supposed to search for it here first. Okay. When you click on find, this comes up. All right. This comes up. Now, why I said this is usually from Aspen Plus is because when you're defining on Aspen Plus, this is what comes out on Aspen Plus when you want to define from Aspen Plus. So you can either type in the components. From here, we have CAS number. CAS number is one of the easiest ways to actually search for things because whenever you put in your component, you can type in the name and then the name might not come out. But once you search for your CAS number, you can check that online. You search for a CS number for a particular component, it gives you a particular number. All you just need to do is to come here, input the number, and then you find your component. All right, so let me just put water in here. Let's wait a little. Okay, still trying to search for water from it. All right, let me quickly search for water CAS number, and then you see that that is even much better. You can search it online, CAS number of water. Okay, now you see I put in water and then it brought out different types of water for me. Understand? We have the distilled water down here, and then we have seawater from magnesium. So it's brought out different types of water. But if you're looking for a specific type of water, like I said, it's easy to just use your CAS number to find it. And then the CAS number for water is 7732 hyphen 18 and then 5. All right, you can search for this. And then you see it brought up water for me. All right, so these are the ways you can go about it. You can either use your CS number or you just type in the company name and then you get it. But using CAS number is far better than just putting the component name so that I don't have to be looking for different things. All right, so let me select my water from here and then add selected compound. It should come here. Water. All right, so we have water added to it now. And then if I'm going to be defining my fluid package, I need to add another fluid package because of this was defined from Aspen properties. So I need to define this from Aspen properties. All right. And then I will select the fluid package I'm going to be using. So we can be using BK because of the stay minutes. You can use your Uniqua or Unifac for it, any of them. Let me select this. And then you can see that it's showing okay. So whenever your fluid package is compatible with your component list, it shows you okay. All right. And you can also see that automatically this is going to define from component list 2, not component list 1. If I select component list, it's not even bringing up component list 1, just component list 2. So we need to take note of this. So there are two things now I've said that's like 2 questions now giving you the answer to in your Aspen exam. The first one is what is the amount of the properties you need to define your hypothetical component. So the two main things you need to define your component list, sorry, your hypothetical component is your molecular weight and then your liquid density. Those are the two main things to note from that. And then the second one is when you're defining your fluid package, if you have your component list from Aspen ICS data bank, what data bank will you use for it? You can either use your, if you are defining from ICS data bank, you have to use the ICS fluid package for it, or is either you're using ICS fluid package or you're using this CompTemo. All right, so this CompTemo also defines from ICS data bank. The only one that is different here is your Aspen properties. So whenever you're defining from Aspen properties, you are getting your component from Aspen properties, your fluid package should be under Aspen properties. If you are getting your component list from ICS data bank, your fluid package should be either from ICS or from CompTemo. All right. If you get that, let me just give me a thumbs up, or if you understand that, just give me a thumbs up, raise your hand so I know that we're following. Okay. Yeah, if you understand that, just let me know. Okay. Ms. Hereta, can you ask a question? It seems like
I'm sorry, can you repeat what you just said about the properties and the costs something? I didn't quite get that, sorry.
all right. So like I said before, when you are defining your component list, let me come back here. If your component list is coming from the ICS data bank, that's this here. If your component list is coming from the ICS data bank, your fluid package can be defined from the ICS or the CompTemo. All right. But if your component list is coming from Aspen properties, now your fluid package can only come from Aspen properties. Do you understand that now?
Yes, thank you.
All right. Mr. Mike, are you following us? Are you with us? All right. Okay. So, all right. Okay, sir. So now we understand.
Yes, I'm following.
All right, sir. All right, sir. All right, sir. So now we already understand this too, which is very important. So whenever you're defining your component list, it's coming from that and then your hypothetical components. All right. So like I said, without those two, you cannot move to your simulation. All right. So once this is done, now you can move to simulation. But before we go further to simulation, now we have some other things to look at. We have the petroleum assay here. All right. So whenever, and then under petroleum assay, you have two things. You have your petroleum assay and then you have your oil manager. So whenever you are going to be doing things that has to do with oil characterization, all right, if you are going to be doing dealing with crude oil, let me use that word now. If you are dealing with your crude oil, there's something we have under crude oil called assay. Now this assay is the should I say template that is used to define your compositions of that crude oil. You understand? That's to tell you the assay contains the viscosity, it contains things like viscosity, the boiling point of your crude oil, the components in it. You understand? The components in it, that's maybe your methane, ethane, propane, thereabouts, down to decane and all that. So those things are found in your assay, you understand, as well as like I said, your viscosity, your true boiling point. All right. Which other thing again? We have a lot. We have a lot when it comes to assay. So when it comes to that, you have to, when you're going to be dealing with things like crude oil itself, when you have an assay to define, is that you're going to be making use of the oil manager, or you're going to be making use of petroleum assay. All right. So when you are making use, petroleum assay is a bit more complicated, more complex than using the oil manager. Usually when you're having your petroleum assay, if your, let's say the company you're working with, let's say NNPC now, they already have their assay already. So maybe you want to work on their, you want to like optimize their process, you understand? You can easily ask them for their assay. Okay, give us your crude oil assay. The assay, that's the crude oil you have been working with, maybe the crude oil coming from Port Harcourt or any other place. So they'll give you the assay for it. You can import this into this petroleum assay here. You can import it here, and then you define some other things in it. All right, and then your usually this like basically from the lab after they've done so many testing. So all the information they've gotten, they can actually put them together and then compile it, and then you can just import it when it comes to the petroleum assay. And then this also has some extra things you'll be adding to it. Let me just try and open it up for us to see. All right, so we can see that it's a bit different. You have to add the assay here. It has the status, it has different things, a bit more complex. You have your density, sulfur, viscosity, thereabouts. All right, so you can see you can generate a report, you can download your assay, and then you can create a new assay. You can see import from the library, import from the file, or manually enter it, any of them. All right, and then let's go to oil manager. When we come to oil manager also is a bit different. All right, can see that oil manager is a bit different. Oil manager, you have to input your assay itself. You have to start the whole definition, or once you're done with your petroleum assay from here, you can improve it under this oil manager by coming to petroleum assay. It directs you back to the petroleum assay, and then you continue the whole process from there. All right, so basically this one is just like an information. Whenever you're working with crude oil, all right, you have to define your assay first, and then before you go to your simulation. All right, so like I said, the first key thing you need to note before you start any simulation: number one, component list. Second thing is your fluid package. After you're done with this, if you don't have the oil manager, if you don't have a petroleum assay to define or whatsoever, you can go straight to your simulation and then continue the process. All right, and then if you have reactions, that's another thing. Once you are working with a process that has reactions, you have to come to reaction here. All right, you have to come to reaction here, and then you define your reaction set. So basically, whenever you get to any unit operation that will be needing you to use your reaction set, you have to define your reaction set first. I can click on add reaction here, and then you select the kind of reaction it is, whether it's a conversion reaction, is it an equilibrium reaction, is it heterogeneous catalytic reaction, is it kinetic reaction, or just the simple rate, any of them. Now another thing to note, if we see our reactant source here, we have ICIS, it's coming from ICIS. Now this one will not be asked in your exam, this one is just for your personal consumption. All right, so whenever you see your reactant source, if it's going to be coming from the ICIS data bank, all right, you select ICIS. But if your reactants are coming from the Aspen properties, you select your Aspen properties. All right, so if you got that, just raise your hand, let me know that everybody's following. If you got that, raise your hand. Okay, just 2 persons.
Excuse me, Mr. Deji.
All
Can you
right.
just go by it?
All right. Okay. Sir, is it from the reaction set? You know how to get to reaction, or just what I said?
Yes, yes, yes. The last thing you said about 30 seconds ago.
All right. So when you are working with your reactants, now you have the reactant source here. Like I said, this one is for your personal consumption. This one is not for the exam. All right. So when you are working with your reactant, if your reactant you are going to be using, the reactants you are going to be using is coming from ICES data bank. That is your component list. If you define your component list from ICES data bank, you select the ICES. But if it's coming from Aspen properties, then you have to select the Aspen properties. That's if your component, the reactant, is in the Aspen properties, then you have to select your Aspen properties. Did you get that, sir?
Yes, yes. Thank you very much.
All right, all right. So, this is recording properly. Okay. All right. So going further now, let's cancel. Let's close this. All right. So you define your reaction sets. So it's asking for. But we're not working with any reaction now, so let's leave this. I can delete this. All right. All right. So with that, like now, okay. Now let me explain. Let's start from the beginning again. The key things you need to note, because the thing is changing as you keep adding more things. It's changing. All right. So if you are working with your component, you start with your component. You get your component list ready first. That's the first thing. The second thing is your fluid package. If you have your what's it called? If you have your petroleum assay, any assay to define your crude oil whatsoever, you go to your oil manager or petroleum assay first before you go to your simulation. Or if you have a reaction, you go to your reaction first before you proceed to your simulation. All right. Now the thing with this reaction thing is that you can even go back once you're defining it. Once you notice that, okay, I think this project I'm working on, we need a reaction. You can easily come back here and define your reaction. The major thing to note is that this is where I have my reaction, and then this is where I'll be defining anything that has to do with reactions. All right. So let's go further. Now we're going to be going to the simulation environment. All right. So I'm going to simulation now. Okay. Can we see? Is my screen still visible? Is it still visible? Can we still see it well?
Yes, yes, it is.
All right.
Yes.
Okay. So I think I should have deleted this. Okay. All right. So let's wait a bit. It's trying to still load to the simulation environment. It's taking its time. I've given it so many tasks to do. All right, so finally we are here. Okay, so now under our simulation environment, when you're done with your properties, you come to your simulation environment. Now we have different things to work with here, and then this thing I'm moving around is known as the model palette. This is where you'll be selecting your unit operations from.
Sorry, I'm not seeing anything.
Oh, it's not showing. Sorry.
Like, The screen is just.
It's not showing too.
Okay, I'm coming. Sorry, I had to change the screen. Okay, I think it's showing now.
Yes, showing.
All right. So we are we can see the model palette are moving around, right?
Yes.
Yes.
Okay. All right, so let's continue. All right, so this is called the model palette. And then in the model palette, this is where you're going to be selecting your streams as well as your unit operations. All right, so all that we have here is your unit operation. Currently is on all. If you're looking for a specific kind of unit operations, you can either come to your dynamic, your control, or your manipulator, whatsoever, piping, reactors, separators, any of them, but currently is on all. So you have all the unit operations right here. Okay, and then you have your streams. Now your stream, you'll be seeing the blue and then you'll be seeing the red. Now your blue stream is representing your material stream. All right, I think all of us are familiar with material and energy balance. I think we should be familiar with that. So when you're working with your materials and everything, this is where you be this is what you'll be using for it, your material stream. All right, is your material stream. This is where you define your components, the specifications of your components, and every other thing. All right, so it's either I select it and then bring it to the environment and drop, or I can double click on it and then it will automatically come up like this. So anyway, but when you're going to be drawing your process flow diagram, it's best to select it and drag it into the environment. All right. So that's your material stream. The red is your energy stream. You can see that it's looking different from your material stream. All right. Then you have your unit operations. So your mixer, your cooler, your heater, heat exchangers, pumps, separators, distillation column, all these things are known as your unit operations. All right, so maybe if you have a question and then it shows you in your question there's a place to write unit operation. All right, once you see that unit operation, you know that okay, this is what it's talking about. This is where I have to select the unit operations from. All right, so you just need to get familiar with that. We have so many unit operations here, and then use it to define your process. All right, so let me see. I just want to, this is a valve. Let me say I want to draw something. Let me add the cooler, and then let me add a pipe with a separator. All right, so this is how you draw your process flow diagram. Kind of just let me see, one is connecting to two. I just want to show you how it looks like. This is not the actual work itself. Two is coming to three, because some of us are not familiar with this software, so just want to show you how it is. And then your pipe, I have three, it's going to four, sorry. And then let me put you there. And then this is your pipe. We have four. We have five. And then we have six. All right. So I think like this now is beginning to make a little sense to some of us. So we can say, all right, so you can see that the stream one is going into the valve, and then from the valve is going into the cooler. From the cooler, it's going into the pipe. From the pipe, is going to a separator. So this is how you go about it when you're going to be drawing your process flow diagrams and all that. So okay, let me leave this. All right, so another thing to take note of now, we have the workbook over here. All right, usually every every unit operation has its own workbook. All right, let me open the valve. It has its own worksheet. Sorry. And then your worksheet is telling you the component that is coming, the material stream coming in and the material stream going out. All right, these are the things to just take note of, few things to take note of. But let's go down to the workbook. All right, so your workbook is giving you your entire streams, all the material streams you've added. Your workbook is actually giving you everything. All right, so this is 1, 2, 3, 4, 5, and 6. These are the material streams you've added. Then your specifications, vapor fraction, temperature, pressure, molar flow, mass flow, liquid flow rates. You can get all of them from here. All right, you can see we have the material stream. When you're looking at the composition, okay, I think, sorry, is anybody asking the question? Okay, no. All right. Sorry, I think I need to extend the call. All right, so this meeting will end soon. Basically, we might have to go off and come back again. All right, so let's just give it a few minutes. In the next 5 minutes, we'll end the section and come back again real quick. All right, so let's just quickly go over what we have to go over now. All right, so coming down to your composition, you can see the methane we defined. We have methane, we have ethane, we have the hypothetical component, as well as water. So that's under composition, still under your workbook. So your workbook is giving you the overview of everything you've added, all the material streams you're using. All right, even the energy stream, we added just one energy stream, which was Q. We added that here. That's this one under the pipe. So it's giving your energy stream. You can also add a new energy stream if you wish. And then unit operations. So all the unit operations we've been adding so far, this is where you can see everything. All right, this is where you can see everything. All right, so coming down here, this is your unit ops. You still see all the unit operations we've added so far. Coming down to stream, you can see all the streams we've added so far, including the energy stream. Then coming down to stream analysis. Now, if it is a particular stream, you want to check the boiling point, the boiling point curve, the CO2 freezing out, whatsoever you're trying to do, the envelope. We're explaining this in one of the sections. We have this envelope here. We're going to be doing that in one of the sections we're going to be having soon. So if you want to define any of this, want to run any stream analysis on your material stream, any of the material stream, you can go over that at this point here. And then you have the equipment design. Let's say there's a particular design equipment you have, and then you're trying to do like a sizing to it, because you're working with some heat exchangers, and then you'll be asked to size the heat exchanger. You have to put in the kind of whether is it vertical, the kind of tubes that are in it, is it the vertical or is it horizontal? You have to define some of those things like that, you understand? Or if you are working with your distillation column, where you have to do some sizing and everything in it, you can actually do that in here, or vessel sizing whatsoever. All right, then you have the model analysis. Now under your model analysis, I think I selected that. You can run different kinds of analysis here. You have property balance, so derivative whatsoever, data table. I think this one is, by the time you have a particular property, we can come to the data table and then we look at the variables in it. So we've not really added much here. So then you have your strip charts. Strip charts, usually you see that when you're working with the dynamic process. And then your case studies, if you have you're trying to vary some components, if you're trying to do things like trying to do sensitivity analysis, we call them sensitivity analysis on Aspen Plus, but they're called case studies here. All right, so maybe you're trying to vary a particular component, like if I increase my temperature from this particular one, that's from material stream 1, if I increase my temperature from here, how does it affect my cooler, or how does it affect the valve, or how does it affect the production of my stream? That's the vapor coming out from 5. You understand? So that's where you do your case study and all that. All right. So we have utility manager, we have the adjust manager, we have the flow packages. All this, it's as we go further, you get more familiar with them. As we go further, you get more familiar with them. Some of the things we have here are still the same thing that is written at the top here. All right. Some of the things down here are still the same thing written at the top. Then you have your economics. When you want to be doing your costing, when you're going to be working with costing, we'll do that too in one of the sessions we're going to be having. We are going to be doing your costing to know how much a particular unit operation will cost. Aspen as can also help us to do that. So you do that under economics. Then also you can check your ROI, that's your return on investment. You can check how long it takes you to get back your initial investment, that's your ROI. You can check the how much it takes for you to operate a particular unit operation. Understand? Because it's not just, it show you how much to install it, and at the same time show you how much you need to operate that particular unit operation. So that's what you do under your economics. All right. And then coming to dynamic, that's when you're moving from steady state to dynamic state. Currently we'll be working with the steady state. Along the line we'll go to dynamic state. All right. Then you have your plan data, then you have your equation oriented. This is usually when you're coming to dynamic states too. In a way, you're working with dynamic states, you get to all this. All right. Then your view, imagine I decide to close this. So these are the kind of things you tend to experience once in a while when we are working with Aspen ISIS. People tend to panic once such a thing happens. Now imagine I tend to close this out. I mistakenly close it out and I need to get it back. I just click on my flow sheet and then it comes back. All right. So whenever you are working and then you mistakenly close your flow sheet, that's your worksheet, everything, you close it, you can easily just come to view, click on flow sheets, and then it comes back. Or you are working with your model palette and then you can't get your model palette, come to view and then select your model palette and then it comes back for you. All right. And then you can have multiple PFDs as well. That's another thing to note. You can have multiple PFDs. This is PFD1. I can decide to add another one, and then this will be a blank sheet. I can work on it. So I can be working on 3 separate PFDs in one simulation. It's possible to do that. It's very, very possible to do that. And then you can also connect them. That's when you'll be using your spreadsheet and some calculators. All right. You can also connect them. All right. So customize. If you have, imagine like a unit operation is not here, I can actually customize a unit operation for myself. If I have the people that did coding and everything, if you have all those parameters, all the equations needed for that unit operation to work, I can define a unit operation for myself that is not Aspen. So they helped us to create such environment for us to do that. All right. Then your resources, then your flow sheet, and then modify, still where you be arranging your flow sheet. Imagine this is not straight. I can decide to flip this, rotate this, or flip it anyhow. So just to arrange your flow sheets, basically. All right. So basically what I'm just trying to do is to get you to know more about this, how to navigate your way around the software, so you don't have to panic around it. Then if you want your temperature to show, or your pressure as your stream label, you can actually select that here. For now we just selected the name to be showing, and then every other thing. So in formats is where you can insert your text. If I decide to insert a text to it, you can type something, process, click OK, and then just put that there. All right. So anyhow you want to go about it. So another thing to note is your SI unit. This is under home. Your SI unit, you can select different kind of SI unit from here. Like now this one is we are working with the temperature is Celsius, our pressure is kPa, that's kilopascal. We have the kilogram per hour for our molar flow, and then the kilogram per hour for the mass flow. All right, so if I want to change this, I don't want to work with this unit, because anything I put in here, they have to be converted to Celsius. Imagine I'm working with Kelvin. Maybe the question is in Kelvin, and then it says that is 325 Kelvin. If I change this to Kelvin here, it will automatically change it back to Celsius. All right, but if you check it very well, it's in Kelvin. I actually imputed it, but it changed to Celsius. So if you don't want to work with Celsius or any of these other units, sorry, you can easily come here and then change your units. You see, now it's in Fahrenheit. I change it to field. I can change it to Euro SI. It changed it to bar. My pressure is in bar now. Depending, or you can define any one yourself. You can define your unit set yourself.
Okay, thank you very much. My question is in reference to the iSpin Tech certification exam.
All right, sir.
Is there a duration for the certification?
Okay, so the way the certification exam is, first of all, let me tell you how the exams will be when you're going to be registering for it. They have time. They have specified times for it. All right. So when it comes to the certification exam from Aspen Tech, they have a specified time for it. You understand? It's not just something you just wake up and register tomorrow. They have like a duration. Maybe the next one might be and it might be next month. I think they have some this month, but they have different times for it. Understand? So when we are done with this class, and then when you are ready to take your exams, we tell you the times that is listed in their own side, and then you pick the one that is suitable for you. You understand? They have that of UK, and then they have that of US. These are the two that I recommend, that of US and UK. So UK, you'll be working with UK time, and then US, you'll be working with US time. US time is usually in the afternoon. The exam is for 4 hours, usually in the afternoon from 2 to 6. That's for US time. And then that of UK time is from 9 a.m., usually 10 a.m. to 2 o'clock. All right. So and the hour, like I said, the exam is for 4 hours. And then when you're done, within the space of, sometimes they are very fast. Under 2 days, they will give you a result. Sometimes you have to wait for 2 weeks for them to give you a result. And then the way this exam work is so that you don't put yourself under pressure. After you take the first exam, all right, if you don't pass the first exam, you can take it a second time. And then the second time is after 3 months. Sorry, after 30 days, after a month, you can take the second exam. If you don't get the second time, like they have, I think it's 2 years, 2 years or so, 2 years span or so. Then the second exam is going to be after the third exam is going to be after 6 months. Gives you enough time to prepare after 6 months. If you don't get that the third time, you have another 6 months again to prepare for it. That's the way they run their program. And then their certificate expires after 3 years. All right, their certificate expires after 3 years. So after 3 years, you'll be required of you to take another exam again. But this exam is not going to be like the first exam. You understand? Just a few questions, just to make sure that you're still up to date. And then you take the exam. Once you pass, they renew your certificate, and then you continue. All right, that is from Aspen Tech. While our own certificates, the certificate we are giving to you, basically what we are even doing is the program we're running is even more than what the Aspen certificate exam is actually going to be asking you, because well, we are going to be running into the dynamic mode. So basically we are training you on how to use this software better. You understand? We're training you on how to use the software better, how to get more familiar with it. And then our certificate is also licensed. Also, the company is registered, and then we have the right to give you our certificate after training. So certificate is like a certificate of participation, and then we certify you based on ascertaining that okay, you have the knowledge to carry out process simulations. All right, so that's basically it for the certificate. Is that clarified, sir?
Yes, thank you, Mr. Shea.
Okay.
Then just another one, just to add,
Okay.
the iSpin Plus software.
Yes,
I
sir.
don't know. Do you have anybody down here that can install it for me?
Okay. If you have installed your Aspen ICs, your Aspen Plus should also be installed. All you just need to do is to search your I think there's a search your Windows. I think there's a place for search there. Just searching, type in plus Aspen Plus, and I think it should come up. You can check that now, Mr. Ochuku. You can check it on your system and confirm. You see Aspen Plus.
Oh, yeah, I'm on it.
All right. Okay. Any other question?
Okay. Thank you. I found it.
All right. All right. All right. That's good. So, any other question? Any other person? Do you have any question to ask before we just do a little roundup of everything we're talking about on Quality Day? Any question again? All right. So as we go further, I'll still be giving you some of the questions that will be coming out from Aspen during the Aspen training. That's your Aspen ICs exam. So I'll be covering some of them as we go along the way. I think, where did I stop? Okay, I think I was here and I was telling you how to change your units. All right. So, okay. If you want to change your unit, like I said, you can come here. Let me go over this again. Your unit operations, you come to unit set, you see under preference, and then you can decide to change the
Please, I
unit.
can't see your screen.
Okay, okay. Oh, sorry, I must start presenting. All right, I think you can see it now.
Yes.
All right. Okay. So let's hit this. Let's hit it on the road. All right. So basically. All right. So let me close all this. I was talking about your units, how you can set your unit. So you click on unit set here under unit of measures. You can easily change it from here. Let me see my temperature. Remember, I put in my temperature at Kelvin, that's 335 Kelvin or so. So I'll just go down to temperature and change the unit from Celsius to Kelvin and then click on OK. All right. So you can see it has changed to Kelvin. So my unit operation now is on Kelvin 325. All right. So that's how you change your unit operation. When you want to, another thing to notice, when you want to send your workbook, everything you've been doing so far, maybe you wanted to send it to Excel sheet, you have the report here. From here you can send it to your Excel sheet and then continue. As you can give a breakdown of the report from Excel sheet. All right, that's why it's put under a summary. All right, so you can do that from there. And then which other thing again? I think that's basically those are the basics for now. I think those are the basics for now. These are the basics for now. So this is just for you to get familiar with the interface for now for Aspen ICs and for Aspen ICs itself. That's your properties and then your simulation environment. All right. So from tomorrow, we'll be posting module 3 and yes, posting module 3. So module 3 is going to run from, that's why we'll be doing different simulations. All right. We'll be doing different simulations. You see the videos, we have different simulations there. And then you practice it on your own. Any question you have, we answer it. Just jot them down. You can ask it directly in the group chat, and then if we can answer it, we'll answer it for you. Not if we'll answer your questions for you. Once you put it on the group chat, we can answer it for you there. But it's best to I would love you to keep your questions down so that we can do it in the live session, so that way as we're answering the question, we can be showing you directly as we're doing it. Understand? So But you can just be keeping down your questions. Everything you can just, so that I don't forget. You can just, once you see it, you can post it down on the post it down in the group, and then we take note of it. All right. If it's something we need to address immediately, we address it immediately to you. So after that, like I said, the module 3, we have about four modules under module 3, 3.1, 3.2, 3.3. I think there's a 3.4, but we'll be posting them from tomorrow. Post 3.1 tomorrow, 3.2 on Friday. Then on Saturday, we have the live sections. We go over the 2 modules that we've posted, and then we continue on Monday. So Sunday is free. Sunday is free. You can use Sunday to just go over everything we've learned so far, and then we proceed on Monday again. All right. Yeah. So that's basically everything for now. All right. Any questions? Any contribution? Anything so far?
You said we are having another live session when?
Another live session is on Saturday, same time. But I'm thinking we should increase the time to like 6 o'clock, because I know some of us will be going to church because of it's Easter Eve.